Good evening everyone, myself Aditya Dutta, currently pursuing my BTech from the Department of Mechanical Engineering at NERIST. So in today's PPT, I'll be discussing about welding and its detailed classification. So this particular topic is from a course name, Manufacturing Processes. So without any further ado, let's get into the detailed classification of this welding. So what is a welding? That is a general question which comes to our mind. So from the definition itself, you can see it is a process of joining materials, typically metals or thermoplastic, by melting the parts and adding a fill materials. Now, if you say about the importance, widely used in manufacturing, constructions, automotive and aerospace industries. Benefits would be a strong bones, cost effective and versatility. That means we can use a welding joints in many purposes. If I speak about the history of welding, forging and early welding techniques was firstly developed in ancient Egypt and Europe. And then in 19th century, the introductions of electric arc and gas welding came into picture. And by the development of the modern advances, the new technologies like laser and ultrasonic welding came into existence. So this was a slight small summary about the history of the welding. Now, what are the basic principles of welding? The basic principles of weldings would be a heat source. That means whatever heat we are providing to create a melt pool, then the filler material, then the shielding. The filler material are basically used to make a stronger bond between the two parent metal component, and shielding is basically provided to make a region safe from contaminations. As we all know that the metals are very much easily exposed to oxidations, right? So in order to avoid such type of situations, we used to make a shielding. Now shielding protects the weld area from contaminants. Now there are various types of welding. The very first is fusion welding and the second is solid state welding. So basically in a fusion welding there will be a melting between the two parent metal, that is an integral point, and in the solid state welding there won't be a melting exactly, but there will be amount of heat generated between the two material which will be sufficient to diffuse the metal parts. So this was a boundary difference between the fusion welding and solid state welding. Again, I'm repeating, in fusion welding there involves a melting part, and in solid state welding there does not involve a melting part, but there will be a heat generated between the material which will be sufficient to diffuse the metal. So let us discuss about the fusion welding in detail. So joining process where the base materials are melted and fused together. So definition is very crystal clear, and there are various types of fusion welding. The very first is gas welding, arc welding, laser welding, electron beam welding and resistance welding. So no doubt we'll be discussing about each of them in detail. Now the very first is arc welding. So it uses an electric arc to melt the metal. Pretty simple. Now if you say about the types of arc welding, it comprises shielded metal arc welding, gas metal arc welding, gas tungsten arc welding, flux cored arc welding. Now, what are the applications and advantages of arc welding? It is versatile and cost effective. That means arc welding is really used in multi-purpose tasks, and also it is cost effective. That means it is cheaper. So these are some of the diagrams of the arc welding which we will be discussing in detail when we'll come into the point of it. So the very first is shielded metal arc welding. So it uses a consumable electrode coated with flux to lay the weld. The flux create a shielding gas and a slag to protect the weld area from contamination. So here in this picture you can see this is a base metal, and here we are using a consumable electrode. Let me take a pen. So here we are using a consumable electrode, and now this consumable electrode are coated with a shielded gas which is put over a weld area, and now this weld area are protected from contaminants. So this was all about the shielded metal arc welding. So from the name itself you can identify that the electrode is covered with a shielding gas. Alright. Next is gas metal arc welding. So it uses a continuous solid wire electrode that is fed through a welding gun and into the weld pool accompanied by a shielding gas. So this is also pretty similar to your shielded metal arc welding. Here The electrode is fed with the help of a gun, and here you can see that consumable electrode is also accompanied by a shielding gas which provides a shield over a welded region, and hence it protects the welded area from contaminants. Thirdly, we have gas tungsten arc welding. It uses a non-consumable tungsten electrode and a separate filler material with an inert gas shield to protect the area. Now in this case, what happens in case of gas tungsten arc material, now this electrode are non-consumable. That means it will not be used up during the welding process. Rather, it has a passage for an arc, and also it has a passage for a tungsten which will be used to join the workpieces, and also it has a separate passage for the shielding gas to pass through it so that it can be protected from the contaminants. So lastly, we have flux core arc welding. It is similar to the gas metal arc welding but uses a tubular wire fixed with flux which creates its shielding gas. Now in this case, what happens, this is similar to the gas metal arc welding, but here you can see this region, this electrode is non-consumable, and this non-consumable electron directly feeds the arc, and along with this arc a shielded gas is produced. The shielded gas is accompanied with this arc, and therefore the welding as well as the shielding both are done side by side. Now this is a gas welding. So gas welding means what? Basically it uses a gas to melt and join the materials. Now this gas will be comparatively very high in temperature, and basic common processes which we use in gas welding is oxyacetylene welding, which we have in our Nehris lab. Now application is to repair work and for thin materials. That means if anything is to be repaired, we can use it by the help of gas welding. And also if you wanted to weld any thin materials, we can use gas welding. The next is resistance welding. So what do we mean by resistance welding? So resistance welding is basically heat generated by the electrical resistance and joins the materials. Now various types of resistance weldings are spot welding, seam welding, and projection welding. Now let us discuss what this resistance welding actually looks like. Let's say this is one particular metal, and here we are having another material, another metal components. Sorry, it shouldn't be coinciding with this. Alright, now let's say this end is connected with one terminal of the wire, and this end is connected with another terminal of the wire. Now what will happen as we pass electricity through them, this region, this sticked region will be experiencing a heat in between them. Now this heat will be so high that these portions will be melted and they will be fused together. So this is a resistance welding basically. So again I'm explaining, suppose here is one component and here is another component, and these two components are joined up or linked up with two terminals of wire or two terminals of any type of conductor, and as you are passing out the electricity through it, what will happen, a heat will be generated at the interface of these two material, and this heat will be so high that it will be enough to melt the material at this interface, and therefore the material will be fused up together, right? So spot welding, seam welding, projection welding, the concept among these three are almost same. And applications is what? It is used in automotive industries and sheet metal industries. So automotive industries basically uses this type of resistance welding, and also the sheet metals. The next is energy beam welding. Now energy beam welding is what? Basically it uses a type of electron or laser beam to fuse the materials. So in this figure it is clearly visible that you can see it is a type of lens. Now this lens is basically used to converge the lasers into a point, and because of this a metals is fused together. So two types of lasers, two types of beam we can use. One is laser beam, another one is electron beam, depending upon the requirements. An application is for precision work and aerospace. The second type of welding after fusion welding is solid state welding. So as I have already mentioned that in solid state welding we do not have a melting process, rather we have a heat generation between the interface of the two materials, and because of this two because of the heat generated between these two, the material is fused up together. Let's say there is one particular metal in this way and there is another material in this way. So now what happens is that We will bring these two material together and will create some sort of friction between them, and because of the friction the heat will be generated and the material will be enough to diffuse up together. In a simple term, what I mean to say is that there will be a heat generated between the interface, but this heat will be lesser than the melting point of these two materials. Therefore, in this type of welding, we do not have a melting point scenario. That means whatever welding we are doing, that is below the melting point of these two materials. Yeah, at certain situations, we will apply some amount of high pressure also, so that the bone can be much more stronger. Now, there are various types of solid state welding. The very first is friction welding, ultrasonic welding, and diffusion welding. An application is for non-ferrous metals. This is very important. And for the plastic joining. Nowadays, we can join a plastics by the help of this type of, solid state welding. So let us come into the friction welding. So what do we mean by friction welding? So friction welding are of basically two types. Number one is rotary friction welding. Another one is linear friction welding. So in rotary friction welding, what we do basically, we'll be rotating one workpiece against the other, which is fixed at the other end, and we'll be applying some amount of pressure over there. So because of this pressure, the material will fuse up together. And in linear friction, what we will do, we will cause a linear motion of one workpiece over the other workpiece, and therefore we will apply some amount of pressure and the material will be joined together. So in this picture, you can clearly see that, let's say this particular shaft or chuck is fixed up and this is rotating in an anti-clockwise manner, and because of the rotation, what is happening, a friction is generated between the interface of these two material, and this friction is generating a heat along with it, and now this heat is sufficient enough to fuse up this two material. Also parallelly, what we can do, we can apply a pressure at the fixed part of the chuck, or we can say that this chuck is movable and it move axially, and as we are applying pressure at the both the ends of the chuck, we can see that along with the heat, the pressure of welding is created here. You see here, the welding is created. So basically, because of the pressure and because of the heat. Hope you have understood this part of the friction welding. The next is ultrasonic welding. So ultrasonic welding basically uses an ultrasonic vibrations to create a friction between the workpieces and then fuses the material. So you can see here we have a transducer and coupler. Now this coupler will be basically providing a ultrasonic vibration, and this vibration will be passed to the material by the help of vibration sonotrope tips. Now when this vibration sonotrope tips will be vibrating to and fro, we will observe that this workpiece will also vibrate, and because of the excessive vibration there will be a friction generated over here, and we know that wherever there is friction there is a heat. So because of the heat, what will happen, these two parts will get fused up together and therefore the welding will be done. So this type of welding is known as ultrasonic welding. Then there is another type of solid state welding that is known as diffusion welding. So in case of diffusion welding, what we can see, we'll see that suppose here we have a workpiece and above this we are putting a welding mold. So and above the welding mold we are applying some uniform pressure. We are applying some uniform pressure, and because of this uniform pressure at certain temperature the workpiece get fused up together. So from the definition you can see a process where two clean flat surfaces are pressed together at high temperature and pressure, allowing the atoms to diffused across the interface. So it is very beautifully said that at certain temperature the two clean workpieces will be allowed to diffused up together or fused up together by the help of the pressure and temperature. That means it is a type of atomic diffusions. In this case the atoms are diffused together by the applications of pressure and temperature. So this was all about the diffusion welding. Now there is one more interesting welding that is known as robotic welding. So if there is any type of components which we have to weld repetitively and otherwise it is very complex to weld, robotic welding comes into scenario in that particular case. So from the definition you can see it is fully automated welding using robotic arms and advanced sensor to perform welding operations in complex and repetitive tasks. So in that case what we will do, we will use robots which will be very skilled to perform the welding which is very difficult to be done in a manual manner. So this is a robotic welding. So robotic welding is actually in a trend nowadays in many of the industries which you will be observing that the robotic weldings are kind of trend, and it has replaced many manual tasks which we individuals had to do. Also, it is less time consuming. Now, when we are doing welding, there must be some safety precautions. The key safety practices and the personal protective equipments, suppose like goggles, aprons, shoes, all these things should be weared properly before you are performing a welding. Now, why we are doing so? Because there might be a risk of burns, electric shocks, and inhalations of the fumes, whatever is coming out from the welding. Now, there are some advantage and disadvantage of weldings. Now, advantage can be the bone will be very strong, it will be durable, flexibility in the material. That means because of the thermal expansion, there won't be much hampering into the material. Now, what are the cons or what are the disadvantages? Now, welding cannot be done by anybody. Whoever is doing the welding, he or she must be a labor. I mean, he or she must be a skilled labor, and also it is a labor intensive, right? It is very labor intensive. So this is a particular quote which is written by me: a good welder never loses their spark. So this is not only about the welding, this is also about a particular life. Whatever you are doing, make sure that you never loses your spark, because your sparks are so important that it can fuse anything in this world. Thank you so much. Hope you have liked this repetitions and presentation.